Welcome to the Green Chemistry class. Now let us discuss about the 12 principles of green chemistry part 1. Do you know about this great personality? He is none other than the father of green chemistry, Professor Paul T. Anastas. Professor Paul T. Anastas and John C. Warner have postulated the following 12 principles of green chemistry in the year of 1998. In this video, we are going to see about first 6 principles of green chemistry. Are you ready to see them one by one? The first principle is prevention. You all know one proverb that prevention is better than cure. Yes, it is absolutely better to prevent waste than to treat or clean up waste after it is formed. We should carry out a synthesis with the minimum or nil formation of waste product. The wastage can be calculated in terms of E factor. Higher E factor means more of wastage. How can you calculate the E factor? E factor formula is given here, is equal to amount of waste divided by amount of product. For example, we are taking the synthesis of salt, potassium tetrachloroplatinate and ethene and HCl reacted together to form the salt. In this reaction, we consider only the amount of product and reactant. First step, the total amount of reactant. Potassium tetrachloroplatinate 4.5 gram, ethene 2 gram, HCl 8.21 gram. Totally it is equal to 14.71 gram. The amount of final product is equal to 3.86 gram. Now you have to calculate the amount of waste. For that, you have to subtract the amount of final product from the total amount of reactants, that is 14.71 minus 3.86 is equal to 10.85 gram. Now you got the value of amount of waste and amount of product. You can substitute in the formula 10.85 by divided by 3.86 is equal to 2.81. Less E factor means less wastage. So this reaction can be considered as a green synthesis. Okay. The second principle is atom economy or the percentage of atom utilization. Synthetic methods should be designed to maximize the combination of all the reactant used into the final product. A synthesis is considered as a green synthesis if there is a maximum incorporation of the starting material into the final product. Formula for atom economy is equal to molecular weight of desired product divided by sum of molecular weight of all substance utilized into 100. For example, we are taking Diels order reaction. In this reaction, diene and dienophile reacted together to form adduct. The answer is 100% atom economy already is given. How it is calculated? So, for the calculation of atom economy, you should calculate the molecular weight of each molecule in the reaction. First, diene. The molecular weight of diene is 54. Molecular weight of dienophile is 70. And the molecular weight of product is 124. Now you can substitute in the above formula. Molecular weight of desired product is 124. They are divided by sum of molecular weight of all substance utilized is 54 plus 70 is equal to 124. So that 124 divided by 124 into 100 is equal to 100% atom economy. So in this similar way, you can calculate the atom economy for Wittig reaction also. Next, third principle is less toxic product. Synthetic methods should be designed to use and generate substances that possess little or no toxicity to human health and the environment. Here you can see a one blue gene which is colored by indigo dye. Generally, indigo dye is used for the coloring process. This is synthesized by conventional method using aniline as starting material. You know, aniline is a highly toxic. Moreover, the synthesis involved a considerable amount of waste salts. This causes disposal problems. So you can go for green reaction. What is the alternative for this aniline? Indigo dye can be prepared enzymatically from tryptophan. Tryptophan is the starting material which is react with tryptophanase, form indole and react with dioxygenase followed by dehydratase to form indoxyl and finally is converted into indigo. Tryptophan is an essential amino acid and also non-toxic. Moreover, this green synthesis involves no toxic wastages. Fourth one is designing safer chemicals. Chemical products should be designed to affect their desired function while minimizing their toxicity. Example, titanium dioxide is commonly used as paint pigment because of their ability to scatter and reflect instant light. The disadvantage in titanium dioxide is its high expensive nature and high energy content. These disadvantages can overcome by using titanium dioxide along with Evoque polymers. Evoque polymers provide improved coverage at lower titanium dioxide levels. Fifth principle is safer solvent and auxiliaries. The use of auxiliary substances should be made unnecessary wherever possible and harmless when used. Organic solvents such as benzene, CCl4, pyridine are toxic and are considered as undesirable solvents. Therefore, organic solvents can be replaced by ionic solvents like water. As far as possible, aqueous phase can be used, otherwise the reaction can be carried out in solid phase to avoid the use of solvent. Here a typical reaction in aqueous phase is the Diels-Alder reactions of furan and malic acid in water medium to give the adduct. Sixth one is minimum energy requirement. You know, energy is the essential thing to carry out the reaction. Most of the chemical reaction take place at high temperature and high pressure. The requirement of energy is minimized by the use of catalyst. Catalysts reduce the energy of activation and thereby increase the rate of reaction. A typical example is given here. The conversion of benzyl chloride into benzyl cyanide using phase transfer catalyst or PTC. PTC is a catalyst that facilitates the migration of reactant from one phase to another phase where reaction occurs. PTC is a special form of heterogeneous catalysis. Without the use of catalyst, the reaction is slow and gives poor yield. Whereas, with the association of PTC, the reaction completed in very short time with high yield. Let us conclude with the summary. The first six principles of green chemistry are prevention, atom economy, less toxic products, designing safer chemicals, safer solvents and auxiliaries, minimum energy requirement. We will see the remaining principles in the next video. Thank you.